Howdy, hackers, and welcome to another episode of FairLight TV. Coding demos is one of the favorite things, or not me coding, but me sort of understanding how demos are coded mostly and being very curious how they did things. We have gone through a number of the demo effects and my favorite demos, and we've looked at how they work. This is an ambition to take the key techniques that are used in demos that you should really have in your toolbox if you would like to be a demo coder on the C64. And I've invited Adam Trident for helping me with that, and we've developed the presentation that we will show, and we will go through it. It will be probably close to 2 hours, but it will be the complete guide to all the epic things you can do with the VIC that the engineers probably didn't understand it could do. So without further ado, over to tricking the VIC. Okay, we've had previous episode of FairLight TV going through a number of VIC tricks, but I thought it would be a good time to do the general grunt work, give you the entire portfolio, the relevant VIC tricks any wannabe demo coder would need to know. And with me, of course, I have the best guy for the job to support us through this, Trident. Adam, how are you?
Hi, I'm good. How are you? Good to be
Yeah.
here.
Finally getting here. We have
Yeah.
spent a humongous amount of hours on the presentation this time. So there will be a PowerPoint supporting us through this with a number of video clips and a number of graphic elements. And I think that one is working quite fine. Do you feel ready to go over to presentation mode?
Let's do it.
Okay. Super. Does it work for you now? Can you see it?
Yeah, I do see the screen. I do see you. I everything is good on my side here. Hopefully
So,
this will go out into the video as well. This is
yes,
good.
yes.
Yeah.
I really hope so. If not, we have failed horribly. So let's start here. The holy trinity of the C64. Jack Tramiel, CEO of Commodore Computer. Commodore starting as a company doing typewriters, I think repairing typewriters, moving into calculators, and then moving into computers. So the part of this Commodore's history that we care the most for is during the years when C64 was the predominant piece of their offering. And we would like to mention the Holy Trinity here. Albert Al Carpentier, the guy that did the VIC, and also the VIC-2, of course, that is the one that sits in the C64. And then we have Bob Yannis, who did the SID, and Chuck Peddle, father of the 6502. It's a variant that sits in the C64. It's a 6510, but for the purpose of this, there is no difference. Anything to add here?
Well, I think wasn't it Al who did the 6510, like the modifications that turned this 6502 into the 6510.
Yes,
I think
and
he
we
said
should
that
also
in some video.
mention that he was the one that did the 6526, the CI chips. He took the
Right.
6511, I think they're called, right? The VIA chips that sits in the drive,
Okay.
fixed a few bugs, and added a few features, and then turned them into the 6526. Yes. So don't forget those four names. They are key to making the C64. And of course, like with all efforts, there is always sort of the champion, and then there are a number of people actually doing the work. So if you know the guy that was the second guy doing the SID, doing a lot of the grunt work, and Bob getting all the credits for it, yeah, so be it. We have just picked the champions here. Sorry about that. All right. And I think one of the things that we should do first is start by defining a number of terms. And I showed a picture of the 6567. Is that the NTSC or
That's it.
PAL one?
Oh, I think it's a good question. I think it's maybe the PAL one with the 65. I think the other one was 65, 66 maybe. I actually don't really know. It is the
Okay.
older version, the first version though, the
Yeah, yeah,
65
the
version.
one
Yeah.
that doesn't have the gray dot bugs.
Right. And maybe
Okay.
the one that doesn't have the full luminance spectrum too, because that's one of the changes of the first few revisions as well. Like
Hmm.
the first one had only four luminance levels, whereas the later one had like six or seven. So
Interesting. I had
the
no idea
colors
they
are
were.
slightly different.
So would they be the ones that sit in the computer that's having the kernel version 0? Is
Oh,
there
I
a
actually wouldn't
correlation
know.
between the two, or because the ones I
I
have are always version 3. So when you do a clear screen, it either picks the value from 0286 or DO21. And so if you want to clear the screen using the kernel routines, you should basically poke a color in both of those two before you do the clear screen, and then you would have it like a consistency between your programs depending on the kernel version. Normally, you don't need to do much to ensure it works on all C64s, but that is one of the really small things that you really should do. Okay,
yeah.
okay, let's move over to a number of the definitions here. In order to sort of be consistent with terms, we are making the assumption that we use the term border for the area outside of the screen, which is what you can sort of address using graphics with the C64 here. What do we call all of it? Frame, right? Or what do you
Yeah,
say
I
is the
guess.
border plus screen?
Yeah, full frame, maybe.
Full frame, yeah, yeah, that
Yeah.
works for me. There is frame here as one of the one of the terms, so I I managed to pick that one right. And then rows and columns, and a row is like the 8 pixel lines that make up a character. So we need to have like a term that defines all of the row, all the raster lines that make up like a character, and then a column would be, yeah, the vertical one. Horizontal blank is also when the raster beam has drawn all of the screen and then starts on the next frame. I think this is what we have here. We don't really use the term horizontal blank, but in other computers, when you're coding stuff, the raster beam draws the line and then it sort of starts again on the next line, and there is a horizontal blank. It's not really used as a term on the C64, but for us old enough to remember mechanical typewriters, a horizontal blank is sort of when you have the machine go bling. All right, and then there is also this thing that you can store stuff to VIC registers, and sometimes it takes immediate effect, and sometimes it doesn't take any immediate effects. Could you elaborate more on that?
Yeah, I guess well, the first thing that important to know about the C64 is that the CPU and the VIC chip are in complete sync. They're in lockstep. They don't do anything out without each other. The one half of each cycle, the VIC chip does its thing. The other half of the cycle, the CPU does its thing. And it's consistent doing it every cycle, everywhere on the screen. So there are no synchronization points or places where you need to be careful, but it's really cycle by cycle. That
Mm.
means that you can time everything using CPU cycles. You know how many cycles each instruction takes, then you know exactly where on the corresponding place on the screen you are. So as long as you get the first point of reference, like
Mm.
you need to know exactly what cycle you're on. But there are, I mean, you've had a bunch of these videos on how to achieve that. But once you've done it, you can just keep counting. There's no other effects. There's no cache effects or anything else happening. It's
Okay.
just the VIC chip and the CPU. And just like the CPU is doing its thing every cycle, it's executing whatever instructions it has in memory. The VIC chip is doing things each cycle as well. And depending on where you are updating the memory locations that correspond to the VIC chip, different things might happen. And this is where what you mentioned is that some of these things happen immediately because the VIC chip is always kind of reading that memory
Mm,
location, and some happen only when the VIC chip is in the state where it is actually reading that memory. So,
mm,
for example, we have the position of the sprites that are
mm,
only read out once, both in the Y direction. It's really just when it starts to display the sprite, it
mm,
cares about the Y position, and on the X position is really at the edge of the screen of the really at the far right when it reads out, starts reading out, and then it kind of goes further. And you can actually move them around until it hits the point on the screen where that matches the X register. So it reads from really all the time. But depending on if they've been shown or not, it depends on whether or not it cares or not.
And you cannot, if we take the sprites as an example, if you've shown one sprite like on the left side, and then you
Yeah,
update the X position to somewhere on the right, it's already sort of gone. You've used it
yeah,
for that line, right?
yeah. And
Yeah.
then it reappears all the way out into the right border. And actually Sprite Zero reappears pretty quickly. So if you open the border, you can see Sprite Zero reappearing, which makes it possible to actually do 9 sprites in a row. Uh, but
But
that
then
one
then
is
you only have, you borrow the sprite
from the
from
next
the
line.
line below. So you need to
Yeah,
have like every second line then, otherwise it
yeah,
wouldn't work.
yeah,
Okay, so and again, where you are, just to point that out, when you're drawing, the raster is drawing, that is the X and Y position of the sort of the raster where it is now. So
yeah,
that's where you are.
yeah.
And yeah, could we also say that it's roughly true that every cycle of the CPU is like one character, so 8 pixels wide? That makes sense, right?
Exactly.
Yeah.
And there
And
are
you also
63 cycles per line. And sometimes the VIC chip steals cycles from you, but that's the base tempo
yeah.
of everything.
And we also said that it's really important that you know exactly on the X and Y position where you are, because sometimes storing to the VIC chip needs to take place on a very specific cycle. And if
Yeah,
you don't have if you don't have full control over exactly where you are, your storage or the storing of the VIC chip would fail and you wouldn't achieve the effect. So that's why we
yeah,
have these stable rasters. And there is a special episode on that. So stable raster is the technique to ensure that you know exactly on which X and Y position you are on the screen. And do watch the stable raster episode for the details on that. I think we've captured a bit of this, but bad lines. So on the first raster line of a row, did I get the terms right
oh,
now? Is a bad line. So that is when the scroll registers of DO11 are this is they those 3 bits are the same as the low 3 bit of DO12, which is the raster counter.
yeah,
I've said raster pointer or raster counter. I don't think it matters, but it shows which line you are, which raster line you are on. And
yeah,
actually, it's sort of the lowest 8 bits of that, because there is also 1 bit of DO11, because we have more than 256 raster lines, and that DO12 register can only hold the lowest 8 of them.
yeah,
And as you already mentioned, there are 63 CPU cycles on a normal line, but on a
yeah,
bad line, the VIC steals up to 40. So the normal case is that it steals 40, but
yeah.
if you're doing a few of the tricks, you can sort of intercept it halfway through, and it would take less.
Yes. And
Yes.
also the what we when we talk about cycles 16 to 56 here, that's really the number of count. We count the cycles from the start of the line
Yeah.
and just 1, 2, 3, 4, 5. So 16 is right about the start of the left border. 56 is like the end of the border, uh, and that's around there where it steals those cycles. I think they're actually shifted a few cycles, like 3 cycles to the left or so, but that's roughly the cycles where we're at.
And also, so if you look at the 6502 instruction, the store instruction, the STA for store accumulator it's 4 cycles, but the
Yeah.
actual storage happens on the last of the 4 cycles, right?
Yeah.
Yeah.
So
Okay.
you need to time it four cycles ahead of time. And that's why sometimes there aren't enough cycles to even get one of those instructions in.
Mm.
So if you have battle lines and sprites, as the typical case where you cannot open the border because there are just too few cycles right there at that crucial moment.
Okay, and the red arrows here are pointing out the first few examples of bad lines here. So that's where it sort of happens because they are the first raster line of a row.
Yeah.
Yes, let's go through a few of the important registers of the VIC and also one sort of external register here that we need to go through. So DO12 counts the current raster line. DO11 bit 0, 1, and 2 horizontal scroll, so the little wiggling up and down you can do. And then you can use bit 3 on and off between 24 and 25. So I think set means 25 rows and 24 if you set it to 0. And why would you want to do that? Yeah, the first important part is if you're scrolling and you would like to hide the scrolling, then all the jiggling up and down, that is hidden. So the border increases and you can wiggle up and down and the screen moves, but the border stays consistent. So if you want to make a scrolling game, for instance, you need to go down to 24 because that is the way to do it. And then there is a display enable. Was that the one that changed in later revisions?
No,
No.
that's just for blanking the screen or not blanking the screen. So
Yeah.
it's when you blank the screen, you don't have any bad lines. So there are more CPU cycles available, which is typically if you want to do something really fast, uh, like load something or something very
Yes.
precise in terms of timing.
And if you are a cracker like me and you used your crunchers, then and you used the Commodore 128, all the
Yeah.
crunchers turn the display off and then enable the 2 megahertz mode, the really, really fast mode that you can run on C64 mode on the 128. And then it will crunch at twice the speed. But if
Oh
you
yeah.
ran that with the display on, it would go totally bonkers. So you didn't want that. So yes, that's also an important bit here.
Yep.
Bitmap mode, so toggling between character mode and bitmap mode. And then there is this weird thing, extended color character mode. Yeah, yeah.
Yeah.
I'm sure you
Yeah.
understand it, but I've gone through this
Yeah.
a number of times and I think it's wonky. It's
Yeah. Yeah. Well, what it does is that it slices the font up. Normally, you
yeah.
have 256 characters in a font, but it slices them up in only a fourth of that. So you have, what is that, 64 letters, and the two highest bits of each character will select what background color
Yeah.
that character will have. So
Yeah.
you can actually have very colorful text screen using ECM mode. But
Yeah,
yeah,
and it's also making weird tricks with the ghost bite, but we will go through that as
well,
well. So
yep,
there are reasons to also remember this. I already referenced the high bit of the raster counter, so this is basically the high bit of DO12. If that one is set, you are on one of the very lowest raster rows of the current frame. Yeah, let's keep to the VIC register. So DO16 is sort of the sister register to DO11, but only on the other direction. So you have the vertical scroll and you have 38 to 40 column. I should do that because 40 is wider than 38. And this is also where you set multicolor mode. But the reset bit was a bit weird, right? That
yeah,
was not really working in the newer versions. It was sort of disabled.
yeah. I think it's disabled. I think it was enabled in one of the early versions of like one of the pre C64 machines. There
Mm,
were a few, like I don't know if they were prototypes or if they were ever like released and used. Uh, maybe they were released in some other area like Japan or something. I don't really remember, but
mm.
it's really not used at all, except for a few very like corner special cases.
Okay. So don't use that because you will never see the effect of it unless you run
Yeah.
it on an emulator that supports it for some reason.
Yeah.
I guess Max could be one of those instances where it actually could work because that
Could
was
be.
a really, really early one, only
Yeah, that
released
that
in
might be.
Japan.
Yeah, that might be the one I was thinking about.
Yeah,
Where you'd, I think it was used by, if it wasn't enabled when you reset the machine, it might break things, or I don't know. But one of those things you don't really need to care about.
right. Yeah, forget about that. Remember all the other ones, but don't spend time remembering that one. So DO18, that's a really flexible register. One is the pointer to the current screen. So one nibble is pointer to the screen. That would be the high 4 bits, and then
Yep.
you have the not the lower 3 bits because bit 0 is not used. It's bit 1,
Yeah.
2, and 3 that points to the current font or
Yep.
to the bitmap, right?
Right.
So
And
depending on if you're in character mode or if you are in bitmap mode, then that one, the lower nibble here works a bit differently.
yeah, and when you're in bitmap mode, there is only really the highest bit that is used. The other ones are not used because you can only
Mm.
select either the high or the low half of each bank.
So it's bit 3,
Uh,
right?
yeah.
Right, right. Okay, and I mean there are a number of registers that affect sprites, but the only one we will cover here is DO17 because that has special meanings for making the tricks that we are going to go through. But there is an episode of general graphics coding if you want to go through all of the sprite registers, but you can watch this episode to cover DO18 because I forgot DO18 in that episode. Okay, and then the really weird thing is that in DD00, so DD100,
Yeah.
you select the VIC bank because VIC can only see 16 kilobytes out
Yeah.
of the 64, but you can
Yeah.
use those 2 bits to set which bank, and they are
Yes.
numbered reverse. So I think you set bit
Yeah.
11 to have it from 0, and then you have it
Yeah.
0 no 10 to have it from 4000, which is totally
Well,
weird, but
you can, if you like, you can actually use DDO2 and then you get them in the other order. Because one of them are, so DDO2 is like a mask, I think, for
yeah.
DDO0. So if you set DDO0 to like 2 bits, like 2 ones to a 3, like you can select a mask in DDO2, you get the same effect, but the order
Uh,
of bits are reversed. So you actually get that 0 to 3 if you prefer that. And
So,
so that
and we didn't prepare that, but then I take the opportunity of asking. I hate DDO00 because you have the serial bus here as well, and if you
yeah,
have a fast
exactly.
loader installed, and if you fiddle
Yeah,
with the DDO00, you can spunk out your fast
yeah,
loader. So it's this is
yes.
a you have to be careful. Would that be a mirror also for? Could you do DDO2 and
Yeah,
kind of make the VIC change without risking the fast loader?
exactly. Yes. So that's one.
Clever.
Some of the there are essentially two ways of doing that. Either you mask out only the low bits in DDO0, or you set them to high and you use the mask to actually set the value.
Mm,
And different fast loaders do that. Use either of those two techniques,
okay.
and uh, it's especially if you're doing demos where sometimes you're doing a demo with using one loader and sometimes you're doing it with the other loader, you need to switch whatever techniques you're using, kind of going
Mm,
back and forth between those two. But
mm.
it's not as easy, it's not hard. It's just a matter of like poking the right register.
Yeah, well, that's the beauty of making demos because you're in control. You are actually
Yeah.
controlling all of it. If you're
Yeah.
making yeah, custom fixes to games, you're not in
Yeah.
control. You have to be really careful that you changed all the instances of where the game is changing stuff. So
Yeah.
Okay, so these are the important ones, and these are the ones you will need to eventually sort of understand for in order to understand all of the stuff that comes now. So let's first look at one of the bugs, or is it? Let's see if we can start that one here. And I can rest assured we haven't sort of done the entire demo here, so or intro here, so. No. Okay, I should stop it now. So the roster bar you're seeing here, the green and white one, again, there is a special episode of this, and this is just repeating what it said in episode 40, but I think it's still rather cute that the roster bar is not a roster bar, it's a sprite bar, and it's the technique is used to have the priority higher and lower than the graphics. So when it goes behind graphics, it still goes in front of one of the colors. So if you look at the dark red part of the logo, it is actually still going in front of that, even if it should go behind the graphics. And are you indicating that we should sort of perceive the dark red one here as part of background graphics?
Yeah. Yes. So I think this is so I kind of grew up with this thinking that this was a kind of a quirk in the Vic chip that you had that kind of shine the sprites would sometimes like cover certain colors, but
Mm.
I realized that it's not a quirk. It's and I don't know. This is a question, I guess, for Al. If this
Yeah.
is a pure design decision or if it is like a happy accident thing.
Yeah.
And because the way that this works is that there are four colors in total. Each character has four colors. Two of them are background colors. Two of them are foreground colors. And really what we're having is four different layers. So at the far back, we have the two background colors, DO21, DO22. And in front of that, we have sprites with DO1, the DO1B bit set to 1. So that takes priority over the most of the kind of the background colors,
Mm.
two background colors. And on top of that, we have the two foreground colors, DO23, D800.
Mm.
And on top of that, we have the highest priority sprites, the ones where DO1B is set to 0. There's really four layers, which means that we cannot use sprites to get behind the background.
No.
It's always in front of the background. So the bug that we're seeing here in the intro, it's not really a bug in terms of the kind of the Vic chip, but really a bug in the way that the intro is done. And I mean, just seeing it here now, I realized that maybe it's not even a raster bar that we were seeing, but maybe what we're seeing is kind of a very thin, like a knife slicing through the
Yeah.
logo, right?
Yeah.
It's like
Yeah.
one of those salami slicer things, like slicing really thin layers out of the logo. So we're really watching this salami intro with a thin slicer slicing off bits of the logo. But really, because it gets behind. I'm just making
I,
this up as I go.
I will die being a firm believer that this is a big a bug in the Vic. A pixel is not background. The pixel is graphics, so it has to be a bug. But I would love to talk to Al Carpenter about
Yeah.
this. I would absolutely
But,
love to do that.
well, the thing with this type of like layers is that you can actually use it and for getting this background foreground effect. In
Yeah,
fact, if you look at the next slide,
yeah.
uh, where this is being used now, this is a demo, and it's like a kind of a homage to the previous intro, but here we're fixing the foreground background issue by having the sprites really go behind the logo, even as far as you can see a black outline of the
Mm,
logo being in front of the sprites. So in this case, and this is from the demo called the demo coder from 2024, and the graphics is by the Sarge. It's actually a custom version of that done for this presentation here. But having those four layers means that we can have a background layer, which is black plus another color. You can see it right here in the G, kind of the opening of the G. There is the background color shining through there, which
mm,
is not the DO21 color, but one of the graphics colors.
Mm.
And the sprites actually passes in front of that and behind the actual logo. So the change here is that this is a bitmap picture. It's not a character screen like we saw in the past in the previous one. So we can have two foreground colors in each character. And if you look at closely at the logo, it's actually a thicker version of the logo, uh, where the white area is 4 pixels wide, and the outside is 2 pixels of the light red.
Mm.
Those are like foreground pixels, so that the sprites will go behind them. And right on the border of that kind of outside are two other pixels. Again, foreground pixels, so the sprites will go behind them.
Mm.
And one is dark red and one is black. So we get that black outline of the logo. And
But but you have one color less to paint the logo with.
that's correct.
You're
Yes.
sort of you're taking away the pinkish one and
Well,
you're making that white.
no,
Um,
the pinkish one is there, except that's only like if you go back and look at the previous screen,
yeah.
uh, you see that the white is only one multicolored pixel thick
Mm.
here, and then there are two like columns of light red, and then there's the dark red
Mm.
on the outside. Uh, what we're doing in the next part is having a little bit of a thicker white, so the logo is a little kind of more robust, more substantial,
Mm.
because the white is really 2 pixels wide.
Yeah.
That means that it's two colors per character now.
Mm.
But yes, certainly fewer colors to paint with because you got
Yeah.
only two foreground colors,
Yeah.
and one of the other is a background color. Uh,
Super.
and I'm sure games were designed to use this. I mean, that was probably the reason why it was there in the first place, that you could
Yeah.
have those kind of background foreground layering things in games. And so that's why I think this was really a design decision. Maybe a happy accident. Maybe it was just easier to do it like that because
Mm.
checking the first pixel, because the background pixels are 0, 0, and 0, 1. The foreground are 1, 0, and 1, 1. So
Yeah.
you just have to look at the first uh, bit there to make the decision. But
Happy accident or bug or deliberate. Yeah.
yeah.
We need to talk to Al about that. So
Oh yeah.
Al, get in touch. We really want to talk to you about this. Okay, yeah, that was that. Then we have this other strange thing. And now we're not blaming Al for this, right? Because Al
No.
had left Commodore when this next generation of VIC turned up.
Yeah. So what we're seeing here is from the demo called That Thing I Hate About Myself, also
Let's
FairLight
see.
2023.
And of course, we're picking all the examples from FairLight where it's
Of
relevant.
course.
So we're not full of ourselves. We're just we know our stuff better than we know everybody else's stuff. So and you have the horizontal ones. That's just storage to the color registers, and the vertical ones, they are using this funny quirk that when you store a color to a color register, there is this little annoying little gray thing at the start of
Yeah.
that store.
Yep.
Why is that? What didn't
Uh,
they see it when they implement it?
yeah, maybe that I actually I don't know. And I think the story that I've heard is that they changed the like the hardware technology between those revisions,
Mm,
and this would be a quirk of that maybe.
mm,
But really what happens is that you get a almost a pixel of white gray.
mm,
It's not necessarily 1 pixel wide. It could be a little tighter even, uh, and it may be a bit flickering, uh, if it even appears. And
mm.
it happens only on some big chips. It happens only under certain conditions. It might go away with like they heat up or they cool down.
Yeah.
You never really know.
It's totally
But
unpredictable
yeah,
because in the demo that we released at Poga Data, we spent a lot of time finding a machine that would actually display it properly. But so yeah, it's a
yeah,
weird thing. There is one little thing that I would like to point out. So a store instruction, that one is 4 cycles. And
yeah,
as we said already before, is that 4 cycles basically means 4 characters on the screen. But here you are making a vertical one and then another vertical one 8 pixels to the right. So you're actually
yeah.
making 2 stores with 1 cycle, where there is a 1 cycle delta between the 2 stores. And let me guess, this is one of the immoral opcodes used for that.
Yeah, yep, I think it is here. So really, the key problem is this, of course, the number of cycles between the stores, and but there are certain instructions on the 6502 that has this little quirk that they store their value twice,
Hmm.
and it is the read, modify, write instructions like increase, decrease, ASL, LSR, the shift
Hmm.
left and right, they do that. So what you can do is that you can, if you do in this case, an increase from color F, so the highest color, increase that to color 0 because it will roll over. You get 1 dot after 5 cycles, and then it will turn black. Actually, that was probably a bad example because you cannot see the first dot there, but that's the kind of the original kind of impetus for this.
Hmm.
Uh, but you can do this with an arithmetic left shift, for example. If you have the value 0 in the register and you do an ASL, it will then read out the value, write the first value back, and then write the second value back. And the second value in this case will be the shifted left version of 0, which is 0. So it will have two zeros written to the color register within 1 cycle of each other, which is what we're seeing there on this the A and the I and the R and the L,
Hmm.
all the letters that are right next to each other have this. And then there
So it's
are
actually not one of the illegal opcodes. Or and just to clarify that, so the 6502 has a number of defined opcodes, but not all of the 256 values are actually defined as opcodes. And if you execute opcodes that or values that are not defined as opcodes, some of them actually work and have most of them are sort of combination of two of the opcodes. If you look at the X and
yeah,
Y in a matrix here, they could have flavors of what's in the column and flavors of what's in the row. And I was absolutely sure it was one of those SAX where it first stores A and then stores X, but it's not. So you are actually
uh,
using one of the normal opcodes here.
I think for this one, it might actually be only normal ones.
Yeah,
There are a
okay.
few, there are a bunch of other places in this demo that I know uses some of the stranger ones, the undocumented ones, but this might actually be only kind of documented.
Mm,
Uh, but certainly I think the SAX is actually would not be useful for this purpose here because it
mm.
actually does only one store. It does a logical AND with the A and the X and then stores that to memory. So it's actually a
Okay.
4 cycle instruction. There are a bunch of the others that are really weird that do these shifts and stuff that a few of them are used in this demo. I'm not sure if it's used right here, but for exactly this effect, to be able
Right.
to set 2 dots within 1 cycle of each other. But I think the
Cool.
real,
And undocumented, I guess, is the formal way to describe them. They are
yeah.
also named illegal, but being a lawyer, I'm sort of hesitant to use illegal because it's not mandated by law in anywhere of the world that you can only use the documented ones. So Adam came up with immoral opcode. So that is just a hilarious way of defining the non-documented ones. So if we sometimes throw terms like that, sorry about that. We're just that's who we are. So That's we're too deep in this shit, I would
Yeah.
imagine.
Oh yeah.
Okay, anything more to say about this?
Uh, Not really.
No.
Well, you can do this on any of the color registers, any of the it happens out anywhere.
Hmm?
But yeah.
It's weird that the opcodes are storing twice because only one of
Yeah.
them would be really relevant. But I
Yeah.
guess it's simplifying something internally for them. Yeah.
Yeah, I think they fixed that in some of the later versions of the chip, but it's really fun because there are other ways where you can use this too. Like there are certain instructions where you do a read in a memory location after the
Mm.
instruction. So the typical use case here is to acknowledge an interrupt
Mm.
by placing the return from interrupt instruction in the memory value, the place in memory right before the timer acknowledgement memory. So the way to acknowledge an interrupt is to read out that memory. But if you do the RTI instruction, you just place it in memory just before this. The CPU will do a 2 byte read when it
Okay.
reads out this, so that it acknowledges the interrupt. So thereby you can save one cycle by doing this. But sometimes that's what you need.
Yeah, sometimes one cycle is a really
Yeah,
precious one. So
very
I
much
would
so.
need
Yeah.
to rewatch the video this video to understand that. But I'm happy I have the original recording then. All right. Yeah, I think we covered all of that. And now for the actual effects. This is just kind of kratta i manegen. Uh, we've said that it's important when you make your store to the relevant register here. And we have sort of three different areas where you can do things. First is row 25. So the last character row of the screen. We will have one effect where you store stuff there to make your effect. And then we have, yeah, they're not numbered really logically here. That's on me. But 3 is when you store stuff on the screen area. And then there is 2, which is it's sort of covering the entire part. Yeah, we will be more specific on the different effects, but this is just sort of getting you into the understanding that it is really important where you place your store if you want to make the effect happen. Sometimes it's really important. Sometimes the wiggle room is a lot bigger, especially in area 1, then the wiggle room is all of the 8 lines basically. Okay, so if we open the lower and upper and lower border, you first set up, before this, you want this trick to happen, you set up the screen to 25 rows, and then you have the raster pointer point beyond row 24 into row 25, and then you change to 24 rows. So the DO11 register that changes to 24 rows. Because what happens then is that Vic would never sort of reach the end of the screen, because you moved the screen up and you yeah you you tricked it into believing that no, we're now in the border, so just keep drawing what you're drawing, don't mind. And then when you pass the last raster line of row 25, then you can put it back to 25 so that you are prepared for 25 at the start of the next screen. Yeah, okay, so yeah, we will, and also do remember how this trick was done, because we will have a look at the other borders, the left and right border. So this will be relevant also for one of the future tricks. Any comments on that, or did I get it mostly right?
Yeah, well, I think you have it's more like 5 lines that you have here. I think
Okay.
it's from $F8 to $FA. That's actually, what is that? It's like 3 lines,
Mm.
maybe even something like that. It's not the full 8, but really 3 lines. But which is easy enough to hit with anything. You can
Mm.
do an interrupt there, and it will just be there.
Well, typically you want to do it on the last line because then otherwise you would have flickering and stuff. So tweaking this to avoid flickering, you still want to
Yeah,
do it on like
yeah, in the middle of the
more narrow.
center.
Technically, you
Yeah.
achieve the effect, but it might look like crap unless you do it properly.
Well, this one's actually really easy to make properly. You don't need to
So.
worry that much about anything. So,
Yes, even I can do it. Yes. So in episode 122, it's not only in 122. There, I've shared my code here for this in a number of episodes, but the most recent one I just quickly found was in episode 122, where I'm looking at this peculiar thing of priority between, if you have sprites, they have a priority between them, and then sprites have a priority in relation to graphics. And if you put all of those on top of each other, you can get really funky things to happen. But do watch episode 122. But on the GitLab repository, I have code for this to share. So if you would like to see how this is done, then just ping, and I would be happy to share the link to that. Yeah, that's that, I guess. FLD. That's also a trick I once were able to pull off. So no need to do any specific setups. But what you basically do is that you ensure that no bad line can happen. So when you are approaching where DO12 is counting up, so the lowest 3 bits would be the same as the lowest 3 bit of DO11, you just change DO11 so that doesn't happen until you reach a point on the screen where you would like the character row to actually appear. And the weird thing here is that you get when you open the gap between two rows, there will be a void, and that void is filled with the last byte of the current VIC bank. So typically 3 FFF if you're having the lowest bank. The weird thing here, which I had no idea about until the demo 9 by LFT, is that if you're having ECM, so extended color mode, it's actually not 3 FFF but 35 FF. Like what?
yep. Yeah. This is because of that 64 character thing where it
Yeah.
just doesn't look at the higher parts of that memory. It
Yeah.
just
Okay.
kind of crops it into the first 512 bytes of whatever bank it's
Mm.
in. So that actually applies to in ECM mode to this ghost byte as well. And this is normally you don't have much. The use case for this is pretty limited, except for that one thing where you'd like to have like one cycle of of latency in setting the byte, so you
Mm.
get another black character there. But maybe the most common use case here is where if you have the highest bank, uh, there is actually collision between FFFF, the
Mm.
ghost byte, and FFFF, the IRQ register.
Mm.
So to get away from that, you can either place your interrupt routine in zero page, or you enable ECM mode, and then you have another. You don't need to worry about that. So that's probably the most common use case for
Mm.
ECM ghost byte mode.
Okay, let's see an example. I'm really happy to show this one. So this is the demo digesta from 1989.
And this is your code. This is your code.
So my demo part, music by Wedge. So Anders Jansson.
Yeah, actually, if you go back and show that again, we could
Yeah.
point out the what you're doing is you're doing the FLD between the lines, and they have normal text lines, but then the black text on blue background
Mm.
between the lines and after the lines, that's the ghost byte that we're seeing, and you're
Yes.
updating that every row. every raster line to
Yeah.
get the text.
I read the DO12 to X, and then I read from a table, which is, I think it says Fairlight the Magicians, very humble as always. And I was almost blushing when showing this demo part because it's so old. But yeah, anyway, thanks for clarifying that. That was a good thing. Yeah, let's do line crunch. Now we're getting into weird stuff. So here
Yeah,
I would need more help to actually understand what happens.
right. So this was it was actually really tricky because the it's a kind of a combination of things happening inside the VIC chip. But basically, what you do is at the start of what would be a bad line. So really at the left of the screen, the first uh, 14 cycles. Well, actually, you can start off the 5 cycles on the right as well. So you have 14 plus uh, 5. So 19 cycles is the
Mm.
window here. And what you do is you start off as a bad line, and they tell the VIC chip that's not actually a bad line. It was uh, it was the I'm not sure if it is you actually tell it that the next line will be a bad line.
Mm.
What happens is that the VIC chip will then count up an entire character line or character row in its internal counters, and it will display that line as the seventh pixel line of whatever mode you're in. So if you're in bitmap mode, it shows the seventh line of a bitmap on that character row that you're on. And if you're in text mode, it shows uh, the seventh pixel of that text line.
Mm.
And there will be no more bad lines. So no more characters are read into memory. You'll keep the characters, you'll keep the colors, but you also will display some graphics. But the what also happens, why this is called line crunch is it will kind of crunch up the entire screen because it increases the counters by one entire entire character row. So it's
Mm.
8 pixels per pixel. So you have effectively shave off 7 pixels per line crunch line. And they can do that movement easily, like vertical movement.
So you're basically taking a character row and you are only showing the
Yeah.
last raster line of that, and
Yes.
there is no opportunity of showing more rows. Can you do this on row 3 or 4 or 5?
No.
You need to crunch away the entire thing. So
Yeah. So it's only the seventh line that happens here. It's really one of the this is it just as happens to be possible to do this. And this
mm,
is definitely not in any kind of design spec for the chip. It just happened to be we were just kind of I wouldn't say abusing it. It's more like an instrument that you're playing it in a new way. It's
mm,
like you have a guitar and you notice that it actually sounds really good if you play it with a beer bottle
yeah.
and it makes a different sound. Like that's what we're doing here. Or a mute. Uh, if you're playing the trombone or the trumpet or
Mm,
something and you use a mute, so surdine,
mm,
uh, where it was super popular. Jazz musicians used all kinds of mutes,
mm,
hats like a bowler
mm,
hat or a plunger, uh, to make different sounds. So you could have like a towel or something
mm,
put in there. It makes different sounds. It's just a different way of using whatever instrument you've got. And we've got the Vic instrument here, and we're
mm.
kind of using it in a different way than it was designed for. But it makes a lot of it just makes us happy, so we do it.
But I mean, it's for me. This is exploiting how the system is designed to
Yeah,
make it perform unintended
yeah,
instructions, and then learning to control that.
yeah, definitely. Yes.
Super. And this is line crunching the basic screen. So this is
Yeah.
showing.
Yeah, this is what happens if you do line crunch on the basic screen. And we see that there are some black characters shown
Yeah.
there. Those are the 24 characters outside of the normally addressable area
Yeah.
and the screen memory. So usually you have like from 1024 to 2040, 2024. So it's actually 1,000 bytes of screen
Yeah.
in that part of memory. Then there are
Yeah.
24 bytes at the end uh, that normally the VIC chip won't show. But if we do this, if we do the line crunch here, it will eat up the one row, and now the counter is when it reaches that point of the screen, it will just happily show those 24 bytes that are otherwise hidden. And in this case, they happen to be zero. So they will be displaying that character zero, which is the at sign. And the same goes for the D800 colors, the last 24 bytes of the D800 colors,
Mm.
which are black because that happened to be zero. And then the rest of the screen is shifted. So everything below that is shifted by 24 characters because the counters are now just messed up. Like they're counting what just completely off the charts.
And
But
out of those 24 characters, the last 8 would be the sprite pointers.
yes.
So
So
if you're going to place information here, it's difficult to combine it with Sprite, or you need to take that into account, I guess.
yeah, you need to take it into account. One way of doing this is to make sure to not show sprites at the exact lines that you have those show those bits or
Mm.
those bytes. Another trick is to simply make sure that the sprites are located in a place that matches whatever you'd like to show there,
Yeah,
which is also doable.
yeah,
Especially
yeah,
if you have if you're in bitmap mode, you have the colors here.
yeah,
So you can actually draw around this. You can make use of just one color, the specific location of the
yeah.
picture, and avoid that altogether. But yeah, this is a trick that you need to kind of get
Yeah,
around.
that's inviting problems. I mean,
It is, and this is why you have like if you're seeing uh, a demo effect with a full screen movement like that, and there are sprites on it,
mm,
and you glance over and you look at the some of the coders in the other part of the room, and you see them, and they are either sweating or really happy or impressed. You know
yeah,
why? Because
yeah,
this is a something that you need to deal with,
yeah.
and it's not at all obvious, but it's there.
And since we're getting to VSP eventually, and where
Yeah.
there you could theoretically bork the VIC chip, is there any negative side effects of this, or is this a sort of a safe effect?
I think this is a safe effect. I've seen some people say that things have been their computers have crashed when
Mm,
line crunch have been used, but I suspect that this has been only because they were actually combining that with VSP.
yeah,
I don't think this will break anything.
right. Okay. And now we will have line crunching using a bitmap picture. And
Yep.
now I fully understand the sort of the offset thing that we're seeing here.
Yeah. So two things to note here. First is the offset, which we saw before. But what we didn't see before is this kind of noise at the top.
Mm,
Uh, and this is that seventh line that we are seeing. So we're kind of seeing that seventh line being crunched together and displayed. So it's really the picture, the seventh line of each picture of each kind of character line that we're seeing crunched up to that state.
mm,
And the colors are whatever the VIC chip happened to have in its internal storage. In this case, it is the last color line that we're reading out before the screen's end. So the previous color line of the last screen is what we're seeing at the top. Uh,
So normally when you do this, you would place sprites on top of this, so the
yeah,
black sprites hiding that, so there would be no issue.
yeah. And actually, this is a great use case. There's one quirk in the VIC chip that we're not really covering here, but you can have just as you can do, you can open the borders. You can actually close the border over the entire screen by setting DO16 at the open of the border.
Ah,
And
okay.
this is one, yeah. So, and here is where
Of
that
course you
actually
can.
comes into good use. Yeah, and where you can cover a line crunch noise like that by using the border color pulled across the screen. But
I've
the
never
interesting,
thought of that being relevant,
yeah,
but yes, of course you can.
it is this is the case. This is the use case for that. But the cool thing though is that because we are actually seeing graphics now when
Mm,
we're doing the line crunch, but we don't have any bad lines. So we have all those 63 cycles left for us. We can do things like showing sprites and open the border, which I think is maybe it's the next slide here.
Yeah.
Yeah. So this is from a 1988 demo by what they call MDT, Micro Development Technology, something fancy. Uh,
Yeah.
but by
It's basically Boogaloo and Exelon.
yeah, the
Two nice
precursor to
guys.
before they joined Horizon. This
Yeah.
is an incredible demo, this Bonanza 1988. They did the first, which we'll see soon, the first VSP plus line crunch, and then they did this. So what they're doing here is completely insane the first time you see it, because they are seemingly showing 7 sprites on top of a bitmap with borders open. And anyone who's ever tried to open the border where there is a bad line of all knows that it's really hard, and you can really only do it with 4 sprites. There is no way to do it with more than 4. But apparently they did it here with 7. So how do they do that? Well, what they're doing is that they're actually line crunching the picture right in the middle. So they're eating up lines just like we saw before, and have designed the picture in a way that it actually matches up everything. So the lines underneath the sprites are that spread out over those 7th pixel line all over memory. And then it's, everything is shifted around in weird places. And then there is another part of this bitmap that we're seeing, which is another part of the memory because they are now, everything is off, all the counters are off. But now we can actually open the border because you got 63 cycles.
Mm.
And, but why did they stop at 7 sprites? Right? Because why not 8? 8 would be like maximum, all of them.
Mm.
Why not 8? And the reason is that the line crunch has to be done before cycle 14. So you had those from cycle 58 to cycle 14. And cycle 58 is actually eaten up by sprite 0. That's when the VIC chip will steal cycles from the CPU to read in the sprite data. And then it keeps going all the way up until cycle 14, which is sprite 7, the 8th
Mm.
sprite. So to get that line crunch right, the right to DO11 in, you cannot have the 8th sprite enabled because it covers the same cycle that we need to make the write into DO11. So that's why you can't do this with more than 7.
I mean, this is absolutely brilliant coding making this happen.
Yeah.
Unfortunately, and this is true for some demo effects, that it's more technically difficult to do them than how impressive they look. And if you don't
Yeah.
understand how difficult it is, there is a great risk that you don't appreciate it for how difficult it is. And I guess this
Oh,
one
yeah.
is one of those. For
This
me,
is,
one of the more annoying parts is that the sprite sort of only disappears. It doesn't float all the way into the left border. But
yeah.
if they've
Well,
just increased the distance between the sprites, and then it would work absolutely fine. So that's not a technical thing. It's just a minor implementation that would have made it look a bit better in my view. But
yeah.
I do
And
appreciate the difficulty here.
And the reason was that, you probably Exelon had his TV set up
Mhm.
with didn't see
Yeah,
all the border.
yeah,
And so it just didn't see it when it
yeah.
didn't.
That could very well be the case. Yeah, yeah. If you haven't seen Bonanza, do watch Bonanza. I think I covered that in one of the coolest
Oh,
demos I've seen. Always,
ah,
this is for sure one of my favorites.
yeah,
All right. So VSP. We will talk about Flea later,
yeah.
and anybody who sort of fiddled with Flea would have bounced into VSP
Hmm.
accidentally, and then you're just annoyed that things freak out. And unless you're one of those people that say, this freaks out. How did that happen? And can I control that? And I'm sorry, I wasn't one of those. Doing my Flea stuff, I was just annoyed that it didn't work. So take us through VSP here.
Yeah, so actually one of the things one of the things, the first thing that to note here is the name. So it's called VSP, which is really kind of annoying name because it sounds a bit like vertical screen positioning,
Mhm.
but it's actually horizontal. We can position the screen horizontally, but it was, and I see now that you you actually added another variant to this, the virtual screen position. The original variant was variable screen position, VSP. Uh,
Okay.
so, but it's one of those things that people get hung up on. Why is it called VSP? It's not vertical. But what it is, allows us to do is to position the screen variably
Mm.
along the horizontal axis, and we can actually scroll everything back and forth by 40 characters. So full screen back and forth with no CPU time. And the the way we do that is by triggering a bad line right in the middle of the screen. So instead of setting DO11 so it will trigger at the start of the screen, we will have the VIC chip in idle mode. So just as we do with an FLD,
Mm.
and then right somewhere in the middle, we just hit it
Mm.
with a bad line. And the VIC chip will say, hey, it was time for a bad line. And it will start there, and then the counters will be off by an offset. So all the counters will be off, and we can just use that to move the screen. We only need to do that once, and then everything moves back and forth. Uh, the tricky part is that you need to get the timing right. You need to be right at the right moment, and you
Mm.
need to wait exactly the right cycles before you can do that crucial right. And then there is that side effect that it's because of how the various chips inside the C64, the PLAs and stuff. I'm not exactly sure how this works in the kind of the hardware level, but what happens is that the memory gets messed up
Mm.
at specific locations. So LFT was the one who figured it out how to get around this. You can actually get around this by not using those memory locations. But
Mm.
normally what happens is that
Mm.
machines just crash in case they're prone to this.
Yeah, when it corrupts part of the memory, and if you have your
Yeah.
code there, or if you have your graphics there, either it's going to crash, or it's going to execute immoral opcodes, which is also a sure way of crashing the machine.
Yep. Some of the immoral ones are really bad, really
Yeah.
immoral. They
All right,
crash.
so we have an example of VSP here, right? So this
Yeah.
is VSP on the basic screen here.
Yeah. So what we're seeing is how we can just move the screen back and forth, uh, like with ease. The only problem is the kind of the little glitch that we're seeing at the top left there. Those are three characters with the character FF, so the highest character in the font, with the color being decided by the low 4 bits of the CPU opcode that
Mm.
follows immediately after the store to DO11. So in this case, I use the opcode EA, which is a no op opcode,
Mm.
and A is the light red color. So we are seeing the light red glitch up to the left there. And it's actually pretty easy to get away with it from this because what you can do is you can create a bad line right after doing the VSP.
Mm.
And that will sort of eat up this because then it will do a real bad line read the next line. And this glitch will only be one line and you can cover it with a border. So it's not really as big of an issue, but I just kept it there for
Mm.
illustration
Mm.
here.
Yeah, that's great. Yeah, yeah. It's not often that we would like to see how the bugs appear, but
Yeah,
that's one of the challenges. If you want to use this effect, then you would need to address this issue. Otherwise, it will
yeah,
not look good.
exactly.
All right. And then we have any given screen position, and this is combining VSP with line crunch, and there is
Yeah.
also FLD, right, as part of the mix to ensure
Uh,
that.
Yeah, I'm not sure if they are using it here, but certainly you could. It's easy to do a tight loop that either does line crunch or FLD
Yeah,
because they are so similar,
yeah.
and you can use that kind of push down the screen and then do a line crunch and all sorts of tricks. But I'm not
I
sure if
think it's
they.
my
Yeah.
assumption that because it starts a bit down to the screen,
Well,
I think they're sort of using FLD to push it down.
the reason it starts way down at the screen is to cover those noisy line
Oh,
crunch lines
okay.
that you get otherwise. So to squeeze an entire screen together, you need 24 lines, which is was that like 3 characters.
Mm.
So and usually you cover that with one sprite and you're good. But here they used a big sprite scroll, so I'm not sure if they needed some more. But this is the same demo that they did the 7 sprites over Bitmap. So they probably figured that one out when doing this. That's my that's my like theory.
But so when you're using this and you would like it to be continuous, you need to update on the sides. When you're
Yeah,
scrolling using VSPs to scroll, you need to put like one column at the end,
yeah,
depending on if you're scrolling left or right. But then you
yeah,
also need to shift stuff at the end, or you just have a
yeah.
shifted variant of the screen and you swap to that one, or how do you do that?
Well, usually, actually, if you run this video here, we can see because what they're doing is showing new graphics moving in from the right, from the left, from the top, from the
Yeah.
bottom, and I think it seems like everything is kind of shifted over because it's not really just one picture. So they probably just feed new data in, don't really care about this 24 character shift and just
Yeah.
use it. They just put new stuff in as
Yeah.
they move stuff up and move stuff down. That's what I would think in this case, because this
Uh,
was like the first. This was the first time
yeah, it
anyone
doesn't
did
really
this.
matter because
No,
it's not a consistent picture. It's
yeah,
little
just new,
patches placed out over the character. Oh yeah, yeah, I get
yeah.
it. Yeah, yeah. Sorry. So
And
because of
later,
the music in the background, sorry for pausing this. It's but let's watch it a bit more then. Oh,
yeah, I actually I don't hear the music, so it might not be on the video.
I
Uh,
do.
but you probably hear it, yeah.
Yeah.
It's a slightly annoying tune. I know this one. It's a bit,
It's fantastic. This demo part is great. It's one of those.
yeah,
And it's also really cool. If you read the scroller, they were saying that no, we're doing this for real. It's not a trick. We are actually kind of
yeah.
shifting. It's just that we learn how to shift data very fast. So they're just
They bullshit.
bullshitting us in the scroller.
And it's really nice. And if you look at now, you have the R there, which has an inconsistent shadowing with,
Yeah.
the highlight is on the wrong place. It's really lovely, naive in so many ways,
Yeah.
this. It's kind of just let's do it, and we do it. And we're just, we're sitting here, what is it, 40 years, 35 years later, talking about it, admiring what like it's so cool that it's really has
Oh,
this lasting effect on
you
us.
mean you should have? Oh yeah, yeah. The R, the middle
Yeah.
one, and where the
Yeah.
white is on the left, right? Yeah, and
It's the
that
wrong
should be on
side.
the right. If we're assuming
Yeah.
and you have the light from the top there, it's wrong.
Yeah. And
Hmm.
it's like they just did it. Don't really care. It's cool enough. And we'll
Yeah,
just do it.
Jürgen and Linus.
Yeah.
That's good
This is
shit.
this is cool. This is cool.
It drove the Horizon guys bonkers when they saw it. They were absolutely flabbergasted. All right, so now we're getting into stuff that might even be easier than the line crunch part. So
Yeah.
FLI, flexible line, interlace, forcing, and I've gone through this in episode 122. So sorry for the repetition, but this is a more comprehensive episode. So we're taking this here as well, and again with a bit of an expert advice here from Adam. You're basically ensuring that you have one bitmap and then you have 8 screens. And since the screens are determining 2 of the colors inside the each of the characters, so the 8 x 8 pixel area, then you can get new of those on every on every raster line. So you get more colors to choose from, or basically you get around one of the key restrictions for the number of colors you can use inside each of the 8 x 8 pixel cells. Yeah, yeah. You just change DO18 and then you provoke it to have a new bad line on every raster line. That's sort of it. Did I get that
Yeah,
right?
that's it.
Yeah.
That's right. It's and the only problem is that to do this, we can't do it too soon. We need to wait until cycle 18, which is three characters into the screen. Because if we do it too soon, the Vic chip will just reset the counters and restart showing the first line again.
Mm.
So we need to be that, wait for those three, or we can wait for more, but at least three cycles in, which is what gives us that flea bug, the three characters of white, gray, or some other color that we see
Yeah,
on
it
flea
was
pictures.
always gray in the beginning. You had this little
Yeah,
block of three colors or three gray
yeah,
or 24 pixels of gray in
yeah,
the left area.
yep,
All right, so we do have an example here, and this
yep.
is Hartalan by Beyond Force.
Charlatan. Yeah, this is the
Charlatan.
first time. This is the first time that this was used ever. Uh, it's coded by Solomon Beyond Force, released in January 1989. And here we see that gray area up on the left, where this bug is uh, positioned. And you also see there is some flickering at the top because he didn't really nail the timing. But it's good enough because it's kind of self-stabilizing after a few rounds.
Mm.
And the scroll text here is complete bullshit of how he used an oscilloscope to figure out and some immoral opcodes and stuff. But it's just, just pure bullshit. It's really fun to read. But which is interesting because he figured out a new Vic trick that would be used for years ahead.
Mm.
And he decided to just bullshit away the scroll text. But this was the first uh, only showing the splits, no
Yeah,
graphics here.
yeah, yeah. When I think of Flea, I think of another Finnish group, Origo.
Yeah,
The ones that won in the Vorby party, the Horizon party and Vorby.
is that El Dorado?
I don't remember the name of the demo. I
Uh,
should remember
yeah,
that,
they.
but
I think they had a.
they had a demo
That
absolutely
was
jam packed with
yeah,
colors, and I think there was a lot of Flea in that.
yeah, it was, and high res flea, and I think the coder's name was actually CLF or colorful. So
Okay. Okay, yeah,
I
we should have known that. Sorry,
yeah,
Torsten. We might add a bit of text here in this
yeah.
part saying we are so sorry we didn't remember, but this is the name of the demo and the name of the coder. You were absolutely great. You did a great job in Vobo.
And that was 1990, I think. So it's really like sometime after this. This was
Mm,
January 1989, and the next picture shows the world's first flea picture, which was in Sophisticated 3 by Blackmail, 20cc, and Inorix in July 89, uh, just a few months later. And I don't know if they probably figured it out by looking at that demo, or if there was this
mm,
they figured out independently at the same time. I don't know, but really, this was the first time that we could see a picture using this green mode,
mm,
and it has all these colors. And like it was popular for some time to do Flea,
mm,
and now it's kind of fallen out of favor because people
mm,
are really good at doing the same type of color, magic
mm.
with better tools and like better knowledge today. And
Yeah, because
but
you're eating all the raster time when you're showing
exactly,
that part of the, and sometimes you need raster time for other things, and
yeah.
you just ask your graphician to shape up and paint nice pictures given the restrictions rather than given additional opportunities.
Yeah, exactly. So yeah, and this is also Flea is also the basis of this good old 4x4 mode, which
Mm,
was very popular in the 90s, where you effectively do a Flea every fourth line, and
mm,
that's it. And so you can't use the first three columns there either, the first three character columns,
mm,
but then you have that 4x4 pixel, like chunky pixels that you can do more
mm.
PC type effects as they were back then,
Yeah,
the late
yeah,
90s. Fall out of favor since then, but
Yeah, yeah,
that
we
was
haven't seen those in a
no.
number of years. So
There was a demo by Oswald and Ed Helen who had found a bunch of old discs that they released in 2024, I think. It was called uh, something like scraping the memory or something. Like they found some old discs and they really did a real 4x4 mode demo. It was really cool. I love it. So I think it was really cool. You did a lot of things with this, but it's full out of favor.
yeah, 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 yeah. So and sometimes that's a good reason to bring it back.
Oh yeah.
All right, so border trick. We have seen the opening of the upper and lower border, and as we already gone through, that you can do without any sort of precision on how you open it. Just store stuff in DO11 within a number of raster lines, and you're good, and it happens. But if you would like to combine it with also opening the borders on the left and the right, then you need absolutely stable rasters. And then you do the trick is technically the same. It's just a lot more difficult because you're storing 38 mode. You're switching from 40 column mode into 38 column mode on the exact correct cycle. If you do it one cycle off, it doesn't work. So you need to store it on the exact right cycle. And that's how you do it. And then you can place a mat of 8 sprites and then repeat. You just do a multiplexer, so you have new 8 sprites and new 8 sprites. And yeah, so 1001 Crew did it first, and they called the technique ESCOS. And there is also an episode of this where I go through it, and I'm also sharing that the source for that. I took the original source and I realized that it could be optimized. They did the trick, but I wanted to optimize the code. So and feel free to pick that up if you want to have a look and use it. There is one little thing. So use an undocumented opcode to write twice to DO16. Would you say that's possible, or was that me bullshitting
Yeah.
here?
It might be both.
They are not mutually exclusive.
It's actually a pretty good idea. So here's the thing. The write twice thing is
Yeah.
true. This is the only way to do this with Sprite 0 on screen. So because you need to hit cycle 56, that's the magic cycle. And I think Sprite 0 starts at 58. So you have to kind of come right in between, just before it starts to steal cycles. And the only way to do that is to use a read, modify, write instruction, one of the 6 cycle instructions like inc or dec. But usually people do this with inc DO16 or dec DO16 to get that kind of go crossing between 8 to 7, or is that like 0 to 7 to 8, or FF to 0, either way. But sometimes that's not good because sometimes you want to preserve, for example, multicolor or a single color mode. And then you can use an ASL or an LSR to do the same. But maybe there is another use case for using one of the undocumented ones to kind of set a specific value there. And actually, as something to think about, I haven't thought about that until now, but it's actually a good idea because sometimes you'd like that. Uh, but yeah, but really, the read modifier write thing is the twice written thing
Yeah.
is what happens. You can actually see it. Usually, you see it when you do when you time this visually. Use it by writing to DO21, and where you can see where you do this thing, and then you see a gray dot
Mm.
right before the border. So that's where the write twice thing is.
Yeah. And then there is this other way of doing it where you actually kind of turn the screen off. So it's all
Yeah.
border and then you apply border opening, and opening a border where there is all border. That's weird, but
Yeah.
you
Well,
can actually do that, and you don't have any bad lines, so you don't need to sort of worry about the bad lines in that in that scenario.
yeah, this is a very useful mode where essentially you open the lower border and then you don't tell the VIC chip to start the screen again. So you have the bits 4 and D11 set to 0
Mm,
when you cross the first line of screen. And then the VIC chip won't show anything more. But what it will just keep the screen blank, but without border. The border will not be visible. But they
mm,
have to open the border again as you reach the lower border. And they have to do that every time. If you miss it by one frame, it will be
mm,
all blank.
mm.
You won't see anything. So you have to be very careful when you do this. But when you do it, you have a full screen with no bad lines. You can use sprites and everything on top of that. Very useful.
Yeah, one thing I forgot to mention when showing the upper and lower border is that uh, you have a high bit for the position, X position of sprites. So you could place sprites beyond position hex 100 or FF.
Yeah.
And that's one bit of DO10 where you do that. There is no corresponding bit for vertically. So this,
Yeah.
if you have sprites in the very top border, they will also appear in the lower border. I guess they are sort of they're skipping the high bit here, and they would
Yeah.
just appear on both of the locations. This was
Yeah.
really confusing for me, but before I realized why this happens.
Yeah. And it can be really annoying, especially if you have them so that they will start and then they start all the way down at the lower end of the screen.
Mm,
And you'd really like to show them at the top,
mm,
but then they've already been started, so now they won't start again.
mm,
So they will flicker and
mm.
yeah, basically the way to deal with this is to turn them off
Yeah,
at some point on the screen and turn them on back on at the top.
yeah. I think that's how I normally do it. Okay, so this is the example from episode 66. And I really wanted the basic screen, so sorry for it taking it so long before the effect starts. But if you just watch this Tutankhamun picture without sort of seeing where it came from, it's just confusing. But so this is filling the entire screen with Sprite, so it's a matte of Sprite, and this is the effect the 1001 crew called Escos. I was stunned.
It's
That's one of
really
those
cool.
instances where I didn't speak for a day after seeing it because I was totally confused.
Yeah. And this is also a case where you need to know the limitations. You need to know how hard it is or
Mm,
impossible it is to do this. And then you see someone doing it and you're like, wow.
mm,
So yes. You need to be able, it's like watching sports when you can't play it. You
mm,
you just don't know. But if you're a golfer, I don't golf myself, but if you see a really good like drive, you
mm.
can feel it. Yeah, I
Yeah,
guess. I mean, you can
yeah,
just,
yeah,
wow,
yeah.
whoa, that was good. Whereas for someone who doesn't know it, would just, yeah, they're just playing golf.
He
You
hit the
never
ball.
know.
How hard can that
Yeah,
be? Yeah.
exactly. So this is the same.
All right.
Oh yes,
Yeah, this is one of the things you added quite lately here. So fill me in
yeah.
on this.
So this is an interesting quirk of the VIC chip, where nominally you'd have 25 lines of text and 200 lines of bitmap. But if you look at the picture here, you see it starts at 1, 2, 3, 4, 5, 25, all the way down to 25. And there's a 26th all the way down. And it's obviously not sprites because there are just too many of them. Too many
Mm,
pixels, too small. And what's happening here is actually if you click to the next picture, is this. So we're opening the borders up and down, and we're pushing the screen so it starts all the way at the top. And then we do this little trick at the bottom, which is we can repeat a character line without triggering a bad line. And I think we'll have another episode talking all about that those types of tricks. But for now, there's just, we know that there is a way to trigger a repeated character line. So what we're doing is triggering a repeated character line all the way down at the end of the 25th character. Now we get it 26th, but it's a repetition of the previous one. So we'll see it's 25 and 25 again. What I did in the last screen is I changed the font. So the
Mm.
last line is in a different font where the 5 is actually a 6. And
Okay, so, but you
if
could
you go
also
back and
point, but you need to change DO18, so you could point to a different screen,
yeah,
and that would also work, I guess.
no, it would not
No?
work because we don't get a bad line. We need to change only the font. We cannot change the character data because it won't read another character line here. But it will actually show bits for another 8 pixel lines. So if you go back to the previous one, what I did was I changed the border color or the background color to make it appear as if we're in the border area. And then I changed also um, I actually use ECM mode here to get that effect that we're seeing because you can't change any of the D800 colors, but uh, to get that kind of weird effect. And you can do this with bitmap as well. So if you check the next slide, I
Yeah.
did the same to the
But this is
you still
also
have
one of the things that is technical brilliance, but it's very difficult to convey the fact that you've actually achieved technical brilliance here because, oh, there's another line. I
yeah,
don't even see it.
no. It's really ridiculous. And if you look at demos where people are using this, so here's one. This is 208 lines of bitmap, and we get that same type of overflow as we saw with the VSP and the line crunch, but
Mm,
we're reusing the same color data as we had on the last line. So
mm.
we're really just showing this. But if you see demos doing this, you almost have to read the scroll text where they say, "Hey, and by the way, look, this picture here is 208 lines."
Yeah. And
Okay,
a number of demo coders are really humble and they don't show
yeah.
it. They just accidentally tell other demo coders at parties and they are the
Yeah,
only ones to know, or they are bullshitting in the scroll text, or some mention it. This is why I'm
yeah.
not a successful demo coder, because my screen would be a big arrow pointing at, look what I've done here. Like,
And even if you
yeah,
do that, people will misunderstand it and not
yeah,
figure it out. It's
yeah,
really,
yeah, for
yeah,
sure.
it's so, yeah.
Okay, we're moving into sprites, and this is rather short, but my favorite again. This one is based on a source code in Dator Magazine by this dude here. I wrote for the Swedish computer magazine Dator Magazine, and I had a series of 2 or 3 episodes on sprites, and I did the dough hook, degkrok in Swedish. Let's see here. Yes. So what you do here is that you have DO17, so the if the sprite is supposed to be extended or not, and you set it to extended, and then you wait a bit and you put it back to not extended, and then you can repeat the same line of, so this is all the top row of the same sprite, and then I'm shifting that, so I'm only shifting it once, and since the same row appears so many times, it's the same shifted contents that appear all across. I could have had some other parts of the sprite in the very end, but again, this is also source that is available in the repository if you would like to have access to it. Yeah, yeah. I don't think there is much to comment about that. That's the degkrok. I think we
Well, the cool
officially should have degkrok as an official English term. We
it
don't,
is. It's a great. It now is. It now is.
yeah. I mean, you learned ombudsman, so why not
Oh,
degkrok?
yeah. Moped is another
Yeah,
loan
yeah.
word from Swedish into English. And now det är krok.
Yes, super. And this one, if I get confused about line crunch and stuff, this is something where LFT has written a remarkably detailed article, and I've read it so many times, And I'm basically clueless. This is
Yeah, yeah,
this
yeah.
is weird shit.
This is like if the other parts of this what we saw was like playing the guitar with a beer bottle.
Yeah.
This is like playing the guitar, but you're unscrewing the string and you're kind of pulling around your head and tying it in a knot on your nose or something. It's just mad. This
Yeah.
is but it's really, I mean, you can dig into this and really figure it out. It's not impossibly hard. But basically the what happens is that the Vic chip is doing, because it's doing things on every cycle. There's that one cycle where it checks if the DO17 is set. And if it is, it will increase the sprite counter by 3. And it sort of does this in a two-step thing. So if you change this register at the right moment, which is, I think, cycle 15, uh, you'll mess up this counter. It will count to with a different increase. I don't know if this is because it's adding first one and then two, or whatever it is doing, but there is something in the logic there that gets messed up. You kind of hit it halfway through the state change, and that gives you this weird way to either prolong. You can extend the sprite because you set it in a state where it will never really reach the end until further down because it adds 3 all the time. And or you can make it shorter. You can hit, depending on where in the sprite, where in the Y, what Y coordinate you hit this in, you will get different effects.
Mm.
Essentially changing the pointer at the kind of the wrong or the right moment.
Mm.
And but what LFT did here is so many ways of so many layers of coolness or slash insanity. Because not only did it do the sprite crunch thing, but also figured out a way to do it dynamically by using the sprite and background collision register,
Mm.
which lets you figure out where. So essentially, it needs to figure out where the sprites end,
Mm.
and that's how it does it by looking at the collision with the background. There is a black color there that's not visible, but of course the collision register will trigger, and it's one of the very few uh, cases of the sprite to background collision register being used in a demo effect.
Yeah.
Uh, this is
And
one of them.
I would say this demo part is one of those. Yeah, it looks nice, but
Yeah.
you don't understand that there are so many worlds first and an
Yeah.
absolute brilliance thrown into this
Yep.
screen that you're seeing. So it's absolutely wild.
Yep. And it's no, it's love it. I love it. This is great.
Yeah, I do agree.
Eh,
I do agree. And that was everything for today. Thank you so
yeah.
much, guys, for watching. I hope you are now on your journey to be experienced demo coders. If this was all news to you, then you are one of our heroes. And if you found it interesting, you just might be one of the upcoming heroes that Adam and I are looking forward to meet and see what you can do once you've seen us unveil a few of the hidden gems that the Vic has in store for you. Thank you so much, Adam. This has been just another pleasure, and looking forward to seeing you again. And guys, thanks for watching FairLight TV, and see you next week, I hope. Bye bye.
This station is now the ultimate power in the universe.
FairLight.